Alright, it's time to work on the booster. So let's find the booster project. So there's 3 steps, or 4 steps plus an optional parts step. Okay, so step 0 is always the whole thing, so we're going to check that out. Now, we're not going to print it this way, obviously, but this is the total height. So the height is bigger than our build volume, but as we're printing it in parts, it doesn't matter. But just to give you an idea what we have to print. So we have to print all these sections in silver. And then this base is going to be in black, and these grid fins are going to be in black. And in this case, there's no heat shield tiles on the booster, so that makes it simpler. And of course, we need the engines on the bottom. So, all right, so we're not going to print that, but let's find the black sections. Let's see. It's not there. Grid fin. Okay, so we need the grid fins. We need 4 of those. So we're going to duplicate those. All right, and then we need the base. So base must be step 3. Basic stand. There's the inner compartments. We're going to print those in that cheaper filament, so like we did for the Starship. Okay, so those are our black parts. So we'll save that as booster black. And the parameters are the same as for the Starship. So we're doing automatic extension width will be 0.48 with our 0.4 millimeter nozzle. Infill 25%. Temperature is the same. Extruder temperature 225. Bed temperature 50. And the cooling is the same. We're putting in PLA, so 0 on the first layer, 100% after that. And the speeds are again the same. So 3,600 millimeters per minute. I found that to be a good speed for PLA on my machine. Might be a little bit faster, but I don't think it matters that much. So I'd rather have a better print. So for some reason, this is a bug in Simplify 3D version 5. It always says this is modified, even though I always say that. But that's okay. Save it again, so then we'll see how long it's going to take to print. Alright, so 3 hours and 47 minutes. This is pretty thick, so it's going to take a while. I don't know why it has to be that thick. That's kind of excessively... Oh, because he wants to put his little logo. Oh, it says Super Heavy Booster on the side. Okay, that's kind of cool. And he's got his logo, which is fine. I don't mind that. And this space has some magnets in it, so the booster will stay upright. There's magnets in the bottom of the booster. The grid fins look like they're going to print okay. Oh, wait a minute. That looks like they're off the bottom. That's not good. Oh, I see. Yeah, so this part needs support. That's not a very good design. Okay. Let's see. Maybe, you know what, we're going to print these differently. We're not going to print them this direction. All right. Yeah, so the good thing I noticed that, because if we tried to print this, you'd print this first part of the axle, let's call it, and then the main part of the grid fin would be at least 3 layers off the grid. I'm surprised Simplify 3D didn't warn us about needing bridging material. Anyways, we're going to fix that, so we're going to get rid of these duplicates. And we're going to say, we're going to print it this direction. Place surface on bed. So we're going to pick this flat area here. Now we're going to print it this way. Now, there's a little bit of a bulge here, but that should print fine the way this is oriented. This is probably print a lot stronger too. Let's see. No, we need 4 of those again. So 1, 2, 3, 4. Now he says that he no, we're not gonna do it that way, but he says that he have already oriented the model to print properly, but I have to disagree in this case. I printed a lot of things sort of like this, and this is going to print a lot better. And because having supports for something like that, the whole thing is going to print better. Now, the only downside is this axle now, there's layers this way. So the axle is going to be weaker than if it was printed on its side. but we're going to take a chance, and this is pretty big diameter, so let's just see how big a diameter that is. Yeah, I think this will be strong enough. Yeah, so we're going to try it this way. If for some reason these axles break off, then we'll figure out something else to do. I may have to make up my own axles where this pin is a separate piece that prints horizontally, and these are printed vertically, and then you plug it in. That would be a better design based on some other stuff I've done. Demonstration. But again, if it's a problem, I could redesign that. This is not that complicated of a model here. I could do this myself. And I printed it 2 parts. There'd be a socket up here. I could print this as a axle that embeds in this socket and glues into this socket here. And then I could print this horizontally, and then it would be a lot stronger because the layer lines would go in this direction instead of this direction. So then if you bend it, then it's not going to break. But I think this will be fine. All right, looks like it came out great. The total time was 4 hours and 12 minutes versus the prediction of 3 hours and 58 minutes. All right, so let's get the preheat going, and we'll get this off on the workbench and see how they came out. All right, so big black base. It's got spots for magnets, and we've got our grid fins here. So just come right off. Yeah, everything came right off. Bottom of this feels good. This feels solid. It's got a nice infill, so it should be good. I'm not sure what this little groove here is for, but anyway. So it says more than 3D on top, limited. That's fine. And then it says super heavy booster, which is nice on the edge. Now these grid fans, the question we had as we were laying out this print, whether this little joint here would be strong enough, this little axle. And it looks like it's pretty strong, so I think it's going to work. So printing them this way means you didn't need any supports. He could have designed this as it was completely flat. You know, the fact that it bulges out, I mean, it's slightly more accurate, but at this scale, well, okay. It's more accurate, so that's fine. Anyway, this printed nice and solid. This is not going to break. All right, so that's the black parts. Now we're going to print the silver parts. All right, so I like that setup here. Actually, I want these two to be, I guess it doesn't matter. They're just going to print these layers, and this one will fit. Then it'll start printing these, and then at some point this one will drop out, and then these will drop out, and then this one will be printing along. And the buttons and back will keep printing each layer. So let's just do it this way. All right, so that's good for their locations. Now a couple of these need supports. So this doesn't need support. These two need supports. All right, so we had good luck on the Starship using 0.3 millimeter support. So we're going to go over here to support generation, and we're going to use 3 millimeter support size. That worked better than 4 millimeter. And we changed this to 88 degrees, which is just. Oh, and we only want to select these two. We don't want to. This will generate supports for these. It might anyway. And he said you don't need supports for the battery inserts, which I agree with that. You don't need supports for that. They're such a small area that it's going to print fine by bridging. So we're going to generate supports for these two objects. So we'll go ahead and do that. All right, so it generated a bunch of supports in the center of this one, in the center of this one. It also generated some supports in these battery things. So we're going to remove those. So we're going to move individual supports. Move this one, these two. So we don't need supports for this, so there's no reason to print it, just more work to remove it. So all we need supports is for the center of these two, because the tops are, solid. There's not. This one is nicely tapered with a hole in the middle, so this one's too short to taper properly. He could have tapered this one, looks like to me. This may not need supports, but he could have tapered it some more and made this thinner, and then you wouldn't need supports for this one, but that's okay. I'm not going to change the model. It's too complicated. So, all right, so that's what we want. Now the parameters are the same we used for the Starship. So we have automatic extrusion, which is 0.848. It'll print faster, even though we have a 0.4 nozzle. Layers, we have 3 solid top layers, bottom layers, and 2 perimeters. And the first layer height is 90, and the first layer's width is 100, and 50% speed on the first layer. And 0.2 millimeter layer height. And the infill, we have 25% infill with a standard rectilinear pattern. The temperatures, well, the supports, let's look at that. I just look at the defaults for these as far as distance to offset from the part, 0.3 millimeters. So, okay. 225 for extruder, 50 degrees for the bed temperature. That's for the PEI surface. That works great. And for my nickel-plated micro Swiss nozzles, 225 is a good temperature for this filament. So, cooling is standard for PLA, 0% on the first layer, 100% after that. Speed, this is the speed I use, 3600. This is the default when I first started using Simplify 3D. I've had good luck with this speed. Might be able to print a little bit faster, but I've tried increasing the speed here and there, and it's chasing diminishing returns, I think. And everything else is standard. So let's just look at, yeah, so I allow gap fill. I like that, extra single wall extrusions. I don't think those are going to come out in this particular print, but we'll see what happens. All right, so let's prepare to print. It's going to be a long one. All right, so 17 hours and 34 minutes. So it's probably at least 18 hours of printing. So this will be an overnight print. Let's look at our support. So like on the Starship, the support material is going this way. We use the same profiles as we did for Starship. And the bridging goes this way, perpendicular, so that's important. Ditto over here. The rest of these are tapered. They don't need supports. And everything looks cool. All right, so we're going to take about 200 grams of material. So I'm keeping track of how much material I'm using for building this. So at the end, I'll have a recap about how much I spent in filament and magnets and everything. So you can get an idea what your budget should be if you want to print this. All right, so let's send this to the printer. And I have a new way of doing time lapses. So I wasn't going to do a time lapse for this one because it's so long, but I figured out a new way to do it, so I'm going to go for it. All right, I've been doing these long-term time-lapse videos of printing using my GoPro. This is a 6. GoPro Hero, I think it's a 6. Anyway, the problem I'm having is if I plug it in because the battery can't last the whole time lapse. So I've been plugging it in with the battery in, and the battery when you recharge it inside the machine, inside the camera, it gets really hot. So and it's hard to get out because it swells up a little bit. So I don't like that. I think it's not good for the battery. So I thought, well, maybe it'll work without the battery if I leave it plugged in. So let's turn it on there. It's a Hero 6, yeah. And it does work. It just shows, instead of showing a battery symbol here, it shows it's plugged in. So we're going to do all our time lapse from now on with the battery out. That'll make me happy because I don't want to overheat the battery. So, and also the big hot thing inside the camera is not that great for the camera either. So you can charge it inside the camera if you don't have your charging block, but I never charge it that way. All right, so we're going to do our time lapse using the GoPro plugged in
the booster. So let's
to the wall power
booster here. So
USB-C
under the booster project, step 0 is the whole thing, which we're not going to print.
Alright, this thing came out great. How long did it take? It took 19 hours and 23 minutes. So predicted 18 hours, or 17 hours and 34 minutes. So pretty far off, almost 2 hours off. Alright, let's get this over to the workbench and we'll check out
That. Now we're going to go to step 1.
Not a super challenging thing.
That's the silver parts. These are all the silver parts. We're going to select all those.
Areas of support.
And then we're going to say center and range. So again, like the other one, we want to print the tall things in the back and the short things in the front. These are all really high quality looking parts. So it's a great design, and my filament worked really well. Here's the hot staging ring. So this has got some really fine grids in it, and they show a little bit of blobbing. So this design probably would have been better if these little grids had been more thicker and fewer of them, even though it wouldn't have been as accurate. But for what we're doing, it's fine. You know, if they look a little bit squiggly, it's fine. So the support material came off, and the base printed super clean. I think this is the other one that had support material, yeah. So as usual, the simplified 3D support material worked great. And this is there's the thrust puck goes into here with magnets. So it's a nice tight fit. Okay, so there's a little bit of few blobs inside of this surface here, so I'll probably sand that down. I'll get some. This is 220 grit sandpaper. I'll get it wet and then sand this out just to make it nice and smooth to the outside. Because these have to nest in with each other, and we want it to come in and out easily. So it's going to be held with magnets. So actually, it might be kind of hard to get that out once there's using a magnet. I guess when the engines are there's going to be engines sticking out of this part. Once the engines are on, there'll be something to grab onto, so you can pull it out. Okay. Yeah, as in the video, he only shows it assembling. It never shows taking it apart. And then I asked him a question. So when this is on the launch mount, the magnets are way up there. So these magnets aren't going to engage with these magnets. But what he said to do was take this piece, flip it over, put it here, and then now, even though that's not how it's actually made, then you can nest the booster on top of this stand so it won't fall over. You could put it on this way. That's what I guess what he does in the video. That's probably fine. But this is going to have all those engines sticking out, so it's going to be kind of flopping around a little bit anyway. So anyway, that looks like a good system. And so we have to print the inside parts, now the hidden parts, and then we'll be ready to assemble the assemble it. So let's see how these grid fins fit. Where's that part here? So let's just see how these fit. So it's a nice tight fit, and a little bit of wiggling, but that's okay. And so that looks like that's gonna be strong enough. So we'll put these in for the final thing when we're done, but they could come out in the box. So I don't want to glue them because they need to be articulated to show how they work. So we'll think about that some more.
Step 4. Yeah, here's the Raptor engine. Okay. All right, so we need 36 of these. So we're just going to duplicate this. It says 36. All right, so that's 36, center and range. Okay. All right, so 36 of those, and we're going to change this to Raptor. We're going to use the same profile. Let's call it Raptor engines. There. Because the burnt orange prints are the same color, same temperatures and cooling and everything. So this will only take an hour and 18 minutes. So that looks good. I think I'm going to center these. Instead of having them over to the side, I'm going to center this first row here. So we'll just, you select all of them, and then you pick 0 for the X. It's going to center them. Okay, so that's better. Then over to the side, that it's going to print smoother if you do it this way. All right, so that's that. And then this is going to take hour and 18 minutes and about 8 grams of material. So that's not very much. Okay, so then we'll send this to the printer, printing in burnt orange. All right, it's time for the hidden parts for the booster. So we've got 8 parts here. For the Starship, we subtracted 1 from the number of parts, multiplied by 3. That's how many the locator pins we needed. But in this case, this particular part here, the thrust puck which has these engines on it, goes into here. It goes into the stand, which I'll show later. So that's going to be connected with magnets, which for the reasons I'll show later. So we aren't going to connect. This is connected with magnets, so we don't need to include this part. So there's 7 parts. It should be 18 locator pins. So this is we're going to start from the top. This is the hot staging ring, where the gas comes out when the second stage ignites while it's still connected. So this goes into this, and that's where the grid fins are, and that's 3 pins. Then this goes into this piece, so that's 6. This is the inner stage. This goes into this piece, which is 9. This goes into this, which is 12. This goes into this, which is 15. And this goes into this. This flips over. That's 18. So it's 18 locator pins. That's what we need. So let's go back to our hidden thing. And then we need to go to the booster, hidden parts, locator pins. So we need 18 of these. So okay. All right, and then we need the internal spline is what I'm calling it. So this is the inner compartment. That's what he calls it. We're going to be gluing this like on the Starship because we're not going to take it apart. There's no internal. Unlike the 1:96 version of this model, there's no internal parts to show. So we're just going to glue everything. It'll be stronger and less hassle. So we need 2 of these actually, because the booster's long. So he split up into 2, which is smart. And we're not going to do the arrange thing because it's going to scatter these around. So we're just going to move this so that it's centered, and then move it to the back. All right, and this one is going to be 35 minus 20. Yeah, okay. All right, then we're going to center all these guys by saying x is 0. That's good. And then we move these a little bit closer. Select all the pins and move them a little bit closer. So the average distance will be minus 20. Let's try that. Yeah, I like that. Okay. Then we're going to select everything and make sure it's centered so it's a little bit off in the Y position. There. All right, so now this is reasonably centered. 32 minutes. So prediction was 5:54, so about a little over half an hour longer or so. All right, I think he's going to come off as soon as I move this thing. So I'm just going to take them off. So these came out really well. And let's take a look at the rest of the stuff over on the workbench. All right, if we can take a closer look here, you can see some of these didn't come out great. The base got messed up, and then it didn't print well after that. So anyway, that's the break sometimes with these small pieces. It's hard to keep them in one place on the sheet because there's such a small contact area. So we lost 2. So we need to make a couple extra. So I already set up the hidden parts for the orbital launch mount, which just consists of these pins. So I'm going to print up a few extra of these pins on the next print. So, if you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.